encompasses what is core to D3. A lot of people think it's like a charting library or a graphing library, but at its core, D3 modifies the document object model based on data. Yeah, it's the core thing that it gives you as a library is it allows you to directly map data attributes to DOM attributes or data attributes to visual attributes. And with that, you get a ton of flexibility. We'll see examples of this in a little bit. It's actually a collection of JavaScript modules. It's not like one big framework. It's about 20 or 30 different smaller modules. There's one module that is core to all of D3. It is D3 selection. That's what allows you to do a lot of the data mapping that I talked about earlier. A lot of the other modules are higher level helper modules that are there to solve common visualization related problems.
Hello.
We got some pizza here.
Right on time.
No? Nice.
Come on in, it's fine.
Yeah. Hello. We'll take a break in a little bit to get some food, but I'll just finish up a little bit. Or maybe should we just break now? I don't know. Who's hungry? So one thing that's really important about D3 that I would like to touch on is that it is expressive. What on earth does this mean? It basically means that with D3 you get a very large diversity of possible visualizations. It's not like something like chart.js where you get 8 chart types baked in. Because D3 is all about modifying the DOM based on data, you can do pretty much anything with it. My experience with D3 has been that like the limiting factor as to what I can make has been my own imagination. We'll go through some examples later, but yeah, D3 can just do a crazy amount of things. And one thing that I've heard a lot of people say about D3, and it's something that I've experienced too myself, is that D3 is very like low level. You kind of have to do everything yourself. You really have to spell things out for D3. And I definitely understand that sentiment. I've been a developer for a couple of years. To actually like dive in and use it because of this. And what I want to say about this is, like, yeah, you do have to specify exactly which data attributes to map to which DOM attributes. And this can seem tedious. No problem. It can seem tedious, but this is actually what gives D3 its power. It does a really good job of making sure that like it gives you very fine-grained granular control over the stuff that actually matters, and then has high-level helper libraries for stuff that you don't need that control over. So yeah, it can be a little low-level. There are spots of it that are very high-level, but it's what makes D3 really great. Pizza time?
Yeah, if we're at a good spot, we take a quick break.
Might as well.
Do you think 5 minutes, 10 minutes? 5 minutes, grab some quick pizza and keep going, keep it rolling. All right, sorry guys.
Yeah, no problem. Pizza's gonna get cold.
I'll go first.
Cool. I might have a slice myself.
Oh, dang, Mason for sure wants to. It's like, hey, there's no sound. Oh, no, it's cool. There's no pausing a live stream.
That's awesome.
Oh yeah.
let's keep going.
All right, we got our pizza. I'd like to thank the people on the live stream for their patience. And I also want to mention, if any of you have any questions, just feel free to stop me and ask. Yeah. So picking up where we left off, what's cool about D3? It sits on top of web standards. When you use D3, you'll be dealing directly with CSS, JavaScript, SVG, all that fun stuff. And it deals with these web standards in a really unobtrusive kind of way. And what this means is, browsers could release a ton of fun new features tomorrow, and we would not have to update the D3 library in order to use them. Like we could get a bunch of new SVG elements, attributes, CSS rules, and D3 deals directly with those things, so we can start using those fun features immediately. It has a declarative API. This is opposed to a imperative API. If you're not familiar with these two programming paradigms, imperative APIs or imperative programming languages kind of describe a series of operations that you need to execute or perform in order to achieve a desired result. Declarative programming sort of describes the desired result that you want to achieve and kind of leaves all of the stuff regarding control flow out of it. As a developer, this is a really good experience because a declarative paradigm is more in line with your mental model of a visualization, whereas an imperative paradigm is more in line with the operational model of your machine. So it works out well for developers. It is transparent and easy to debug. D3, well, other charting libraries like HighCharts, there's an API, and then there's the library, and then there's the DOM. They have this intermediate representation. There's a lot of magic that happens under the hood, and there isn't a clear representation between the API and the stuff that actually appears in the DOM. With D3, the API is modifying the DOM directly. There is no intermediate representation. The object model of your visualization is the DOM itself. So D3 works extremely well with your Chrome developer tools because you can inspect the object model of your visualization just right there. What's not so cool about D3? It does require a relatively good working knowledge of web standards, HTML, CSS, SVG, and JavaScript. This means it has a little bit higher barrier of entry, but this is something that I think could be cool. It does require more knowledge, but you can also use D3 as an excuse to learn some cool new technologies. I've been a developer for a couple of years, as I said, and it wasn't until I started learning about SVG that it wasn't until that I started learning about D3 that I started learning about SVG. Like, this was an excuse to learn some new web technologies. What's also neat about this is, say you decide to ditch D3 and go with some other visualization tool, you get to bring all of your knowledge of these web standards with you. It's not like switching from React to Angular, where you kind of just have to leave your React knowledge behind and learn something completely new. There's a steeper learning curve, and it does take more time to implement. I think at the end of the day, one of your main responsibilities as a developer, you still have to make intelligent decisions about the choices you make regarding picking the right tool for the job. If you have a client that needs a simple bar chart made in 2 hours or something like that, D3 is going to be a poor choice for you. So there are other good charting libraries out there. Yeah, it's all about picking the right tool for the job. So, diving into SVG, if you're going to be using D3, you'll be most commonly dealing with SVG. D3 also deals with the Canvas API, but most of the time you'll be using SVG. SVG would be the subject of a whole nother talk. It's a specification which is just absolutely massive, but luckily there's just a handful of elements and concepts to know that will get you most of the way through D3. So if we take something like this, it's going to produce an illustration like this. There's a great tutorial, and I'll show you these links at the end, and also the link to the slide deck at the end. But there's a great tutorial on the Mozilla Developer Network for all this SVG stuff, which will get you most of the way through D3. But generally, you need to know what an SVG container is. These groups, these are like the div of SVG. They just group a bunch of child elements. These are nice because you can perform a transform on the group, which gets applied to all their children. So if you want to move a bunch of stuff around, put them in a group and then transform the group. There are lines, rectangles, circles. A lot of those have X and Y attributes, width and height. You can take a look at those in the tutorial. Path here is the most powerful SVG element that there is. It has this D attribute, which has this crazy looking string in the middle, and what this is used for is for drawing complex curves and shapes. You don't have to know what any of this means. D3 is going to take care of this crazy string for you. There's a nice shape library that comes with D3, which lets you generate stars, diamonds, squares, paths, areas, pie charts, whatever. Just, you don't have to worry about what that actually means. There's text, SVG elements, and then for an object is kind of interesting. For an object, it lets you put HTML in your SVG. This can be useful if you want to apply some CSS rules that only apply to HTML elements and not SVG ones. So I have a small example of that later. Any questions so far? I do want to talk about SVG coordinates. They are a little strange. Here we have an SVG container. It has a coordinate system, and in the upper left corner is the origin. That's x of 0, y of 0. As we move right, the x value increases, and as we move down, the y value increases. This is strange because this is backwards to what we learned back in high school in algebra, you know. But it's just how browsers work. As you move down the page, y values are going to increase. If you use a group inside your SVG, it's going to have its own coordinate system, and if you transform this group, that coordinate system is going to move with the group. This can be something that's extremely useful. This technique here, where we translate a group by half of its parent's width and half of its parent's height, what this does is it centers the origin of this coordinate system in the middle of the SVG container. This is a really common technique to use with D3 if you ever want to make a graph where the origin is in the middle of your container, basically like every graph you saw in high school algebra. This is how you can accomplish that. Talking about DOM manipulation for a second. Say we wanted to take these rectangles which have no attributes on them and turn them into this simple bar chart. We can use vanilla JavaScript, which is fine to use, but it can quickly become cumbersome. And here, this probably looks relatively familiar. We create a selection of these elements by passing in a CSS selector, correct? We create a selection, we iterate over this selection, and then we set attributes on each element of this selection. Here using the index of the selection. So we're setting x of 0 on everything, y is a multiple of the index, width is also a multiple of the index. We're setting height and stroke of white to these lines here. We can use something like jQuery to accomplish this. Here we make a selection by passing it a CSS selector. Actually, use my mouse here. Yeah. And then there are a bunch of these chainable methods that we can use to set the same attributes. D3 looks very similar. Like it looks almost identical. But the big difference between D3 and jQuery is D3 has a way of binding selections to data. And that's what the D in these function sets. That's what the D stands for. It's a common D3 convention, just to use that single letter variable name. But we will see how that works in a second. So here's some live code. This is like hello world with D3. I've got this data array right here. And what we're doing is we're selecting an SVG element. There are no rectangles in this HTML page. It's just an empty SVG element. We're selecting all of the rectangles in it, which there are none, which is kind of weird, but I'll explain that in a second. We're binding it to the data array. We're calling inter to get all of the data that's new. We're appending a rectangle to each piece of new data, and then we're setting all the same attributes that we were before. Here for width, we're just passing a function which returns data. This is where we are binding data attributes to DOM attributes. Here, the width is going to be a function of our data. This is what D3, the data-driven document, is all about. And to just show an example, say we added 50 is going to make the chart grow. So yeah, there will be more examples of this going forward. So D3 selection is the kernel of D3. It is the most important module in all of D3. It creates selection objects, and we're pretty familiar with this if we've used jQuery or the vanilla JS example that I was showing you before. You can select just one element with D3 select, or select all matching elements based on the CSS selector with select all. These selections have a large variety of operators that we can call on them. These should be very familiar if you're used to attributes that are the properties that are on HTML elements. You can create subselections from a selection to select on select. We can bind a selection to data. We can filter a selection by passing in a function. We can merge a selection with another selection, and then here we can set attributes as a function of data, style properties as a function of data, text. We can set CSS classes as a function of data, DOM event handlers, properties, HTML, and then we can even add or remove elements to a selection. So there's a lot to cover here, but hopefully they're familiar topics to people that have done some front-end work already. Questions?
When you say as a function of data,
Mm-hmm.
do you have more examples of that coming up, or can you sort of speak to what that means?
Yeah. Going back to this one. So here we're setting width as a function of data, and this is just kind of like an identity function. It's just returning the value that it's getting. But it's basically setting the width of these 7 elements based on, there's like 1 element per piece of data here. So the first one's going to have a width of 30, second one's going to have a width of 120. And that's what this is specifying. It's sort of, the function is describing how to map your data to your DOM attribute. So we will see more complex ways of doing that in a little bit here. The data join is a really important concept. This one took me a couple weeks to grasp, but it's really important in D3. So we've already seen that we can select a bunch of elements and bind it to data. In this example, it doesn't matter how many elements we're dealing with initially. There could be 0, there could be 1,000. But what's kind of interesting about this is select all will return 1 selection. When we bind it to data, this is going to return 3 selections, which is kind of strange, but they're represented over here. It's going to have a selection for all the pieces of data that don't have a corresponding DOM node, all of the DOM nodes that no longer have data associated with them, and then for update, these are all the DOM elements that still have data, where the data might have been updated. And we can access these 3 selections. This variable that we save is our update selection. When we call this inter method, this accesses all of the pieces of data that don't have DOM elements associated with them. The most common operator to use after this inter method is append, because we want to make a new DOM element for a piece of data that doesn't have a DOM element. And then we can access all of the elements that no longer have data with exit. The most common thing to do here is to remove them from the DOM. We can use this in what's called a general update pattern. I have a working example of this later, but basically we take a selection, bind it to data, and then we can perform operations on our update, enter, and exit selections. It's really nice to take all this code and put it in one function which accepts your data as an argument, because you can call this function 60 times a second if you want. It's just really efficient. But it also, we can start to see how we're describing what our data should look like. This is where the declarative API is sort of starting to come to life. So there is a working example of this in a second, but is this kind of making sense?
Is data always expecting like a one-dimensional just array of data, of numbers? It's
Good question. Yeah, it's basically just accepting or expecting an array of any value. So it can be an array of objects. But it can accept data that's a tree too, so it can accept an object that has an array of children. And there are ways to actually deal with that data structure.
In this example, are we expecting data to already be set? The variable data?
Yeah.
Okay.
Yeah. It's just going to be an array of stuff. So the D3 module ecosystem is pretty large. And I definitely don't have time to cover all of it tonight. But so we went over D3 selection, which is the one you'd probably be using most commonly. But the rest of these are, some very high-level libraries that help you out with some common visualization-related tasks. When you import D3 or download it from the CDN, you're getting all of this. So you don't have to worry about importing an individual module, except that it can be a good practice if you want to try and reduce your bundle size in an application. You might just want to import the specific modules you need. But the most common ones that you'll probably end up using are D3 axis. This draws axes. D3 drag, this is for drag and drop. D3 scale, I'll cover that in a second. D3 selection, we covered that. D3 shape, this makes complex shapes for your path SVG elements. D3 transition, this makes smooth animations. Has a very similar declarative API as D3 selection. And then D3 zoom, this is for zooming in and out using your mouse wheel. So D3 scale is a really important one, and you'd probably end up using it on most of your visualizations. So you have some data that's numerical and you want to display it in a bar chart. Your numerical data might be on one scale and you need to convert that to a pixel value for the bar chart. The bars have to be a certain number of pixels high. So as an example, let's say we have some weather data that's between 32 degrees Fahrenheit and 90 degrees, and we want to display that in a bar chart that is going to be 600 pixels high. We need some kind of function that will map our data to these pixel values, and we can use D3 scale for that. It allows us to move between these two different scales. This looks like this. We call it D3.scaleLinear. We set a domain between 32 and 90 and a range between 0 and 100. This gives us a function which has a lot of methods on it, but the function that we get is xScale. Normally this is called x, but it's just a function that accepts a number and returns a number. So some examples, if we call this function with the value of 32, we're going to get 0 because 32 is mapped to 0. If we call a number in the middle, like 60, we'll get a number in the middle, 289 in this case. It also has a property invert, which is also a function which just goes the other way. It maps from pixels like 600, it'll map it down to 90. This can be really useful if you're dealing with mouse events, because mouse events are always going to be in pixels, and if you want to do like a drag and drop operation and convert that back to data, you'll need to use the invert function. D3 axis, great module for drawing axes. And here's just a live example of how to do it.
Hey, can everyone see that? Is there any way to bump that up? Awesome. I posted a link to the slides on the meetup if you guys want to follow along.
Yeah, and if I'm going too fast, feel free to come back to the selection or these slides. All the live code will be here, and all these examples will be here still.
And if you think it's really cool and you want to see it later, it's all going to be on YouTube as well.
I think that's as big as it'll go. But so one thing that's really important to do in D3 is just if you have a width or some kind of pixel size you want to save, this is just going to be the width of our container. Just save it with a variable. That way you can use it in a bunch of different spots elsewhere in your code. But here we're creating a scale, just like the previous example. And then down here we're selecting our SVG container, which is just empty right now. Setting the width attribute on it with the attribute operator. And then we're using call, which will just call a function that accepts a selection as an argument. And that function is being produced by D3.axisBottom. And when you make this axis, it needs a scale as its argument. And that draws this axis over here. So to make an axis, you need a scale first. But what's neat about this is, you can change the domain, and the scale updates automatically. And D3 does a really good job of automatically formatting your values. So this is one example here where D3 is not low level. We're making this whole axis with just a couple lines of code, but it does give you a very fine-grained granular control over the most important part, which is going to be your scale. if we combine this with the zoom module, we're not adding a whole lot of code here. Same thing as before, we're making a scale, we're drawing the axis, but down here we're defining a zoom behavior with D3.zoom, and we're going to assign an event listener listening for this zoom event that D3 emits. And whenever an event is emitted in D3, it populates D3.event, which is populated with information about the event, but only during the event. So we can use it inside this function. So D3.event.transform has a method on it called Rescale. And what this allows you to do is you can pass a scale to Rescale, and it'll return a new scale, which is like your zoomed scale. It automatically adjusts the domain and range of your previous scale for you in accordance with whatever you did with your mouse wheel. And then we can just call the same function that we did before, but we are passing the new zoomed scale to axis bottom. And then we just have to assign the zoom behavior to an element. So if I now hover over this axis and zoom in, it gives you a really nice pan and zoom transition, and it very nicely formats the numbers for you. So this is a really neat behavior, and it didn't take a lot of code. And what is commonly done is you take your new zoomed scale and then pass that to your general update pattern too, and it'll apply the new scale to your data. So if you want to just scale like some bars on here or something like that, that's how you do it. What's fun to do here is instead of using scale linear, we can use scale time, and this gives you a scale based on Unix time. So it's going to start in 1970, but as we zoom out, this is now a time scale, and it will show you minutes, milliseconds. Zoom out far enough, it'll show you hours. Yeah, there's 1970. Days of the week, months. It automatically formats all the values for you, and you can go out to years. So this is yet another example of just how D3 is actually high level. This didn't really take a whole lot of work. It's just a couple of lines of code.
Is there a lot happening in your CSS file, or is that pretty much how it's going to look without a whole lot of styling?
This is pretty much how it's going to look. The only thing in the CSS file is overflow visible on the SVG element.
Yeah.
That's it. Just so it doesn't cut off stuff on the end.
So if you wanted to style the font of the anything like that, would that be like an override for what is printed kind of thing, so that it would follow the CSS of whatever's on the page?
That's a good question. So the labels, the line going across, and all the ticks have class names assigned to them. So if you ever did want to adjust the style, you can do that all in your CSS.
But the font name for Isma is by default probably set, but it's not set, right? It's whatever is the default.
I suppose. I haven't really looked into that. But yeah, you can definitely set a new font just by using a CSS class that it automatically assigns.
Say it defaults to 1970, you start to change that, right?
Yeah, and it's actually just defaulting to 1970 because I set a domain of like 10. So that's 10 milliseconds after 1970.
And it's 1970 because it's Unix time, right?
Correct, yeah.
So yeah, just all time is Unix time since 1970. Time does not exist in computers since before that.
This is a negative.
It's painful. It's painful. It doesn't exist.
So I'm going to walk you all through how to build this bar chart here. I still have a lot to cover, so I might go a little quickly, but all the code will be in these slides that you can come back to. So this chart is driven by real data. It reaches out to the GitHub API and gets all of the top repos by number of stars. We can also look at the number of forks. So these are all the top repos by the number of forks. It's got some cool transitions here. And they're very pretty, but they're also useful. There's this concept called object constancy, and if you imagine switching between these two states instantly, your eye's gonna have a hard time detecting what data is staying the same between the two states. But applying these smooth transitions, it makes it really easy to see like, oh, TensorFlow and Bootstrap, I think gitignore, like you can see what data is staying the same between these two states. Does that kind of make sense?
Yeah.
Also want to point out that we have D3 here as number 9 as most stars. So the first thing you want to do, and this is what I recommend if you're not super familiar with D3, is build out something basic using only SVG and CSS. This will teach you a lot about what you need to make with your D3, and it's a really important step because if you can't really build something in raw SVG alone, I don't think you'll know what to do with D3, but it's good practice. Once you get something like that, we can make the same thing but based off of real data. So here we're dealing with just another empty SVG element. I made a data file here. It's just an array of objects with a width property. And this is a lot of the same stuff that we saw. We have a selection, bind it to data. Here with the inter method, we're getting the inter selection. We were appending rectangles, and then we were setting a bunch of attributes. And we were setting width, the width attribute as a function of the width attribute on our data. Next thing we can do is add a scale. So we've seen this code before. Well, not this code, but we've seen the scale stuff before. Same code as the previous example, but here we're making a linear scale, saving it to the variable x. And there's this utility function that here I'm using D3.max. And this is just finding the largest width value in our data and setting it as the highest number in our domain. So our domain is going to be between 0 and just the largest width that we have. And then we take the scale function, and again, it accepts a number and returns a number. So we're just using it down here in our width function. We are calling the scale with our width, and that is scaling the data. And to show you what it does without it, you can take it out, and our data is no longer scaled to our container. So if we add that back in, it applies the scale. And since the scale is being adjusted based on the largest width, we can increase the value here and notice how the rest of the data automatically scales down. So
Is the scale, device, doesn't device dependent,
it isn't device dependent. Scale is it's basically just a JavaScript function that does some math. So it takes in a number and returns a number that has had some mathematical.
in terms of like mobile or desktop kind of
Oh,
So is it absolute then?
Is it based on the window
Right.
or
Oh.
the container?
yeah, and here I have it. Or wait, where is it? It's based off of whatever you want it to be based off of. Oftentimes you set the range between like 0 and the size of your container. That can all be changed. Like it's not hard coded to anything. It's completely up to you. There's in a couple slides here. I'm setting it to something other than the width of the container, which I'll show you.
I think in this case, the container is just the browser, so yes, the device.
Yeah.
What if you have the SVG and you have this in a group? And the group is, maybe like moved, transformed, right? Would it be like dependent on the group?
Can you repeat the question too, just so people at home?
Yeah. So is the scale dependent on the group?
Yeah.
No. So the scale just has your domain and your range, and it gives you that function which just applies math, but you get to use the scale wherever you want. So you can set it to your width, you can, you can use it wherever you want, you can use it wherever you don't want, and like in this example, I'm setting the range equal to the container, but you can set the range equal to whatever you want. Like if you only want to display some data in like a very small section, then set your range to that. So this is the general update pattern in action. I just wrote some function down here to take the data array that we had previously, shuffle it up, randomly slice it, and then we're calling a draw function here, which has our general update pattern in it, and it's accepting data as an argument. So we're going to be setting the domain of our scale inside the draw function because our data is going to be changing, and D3.max will grab our largest width. And then this is the general update pattern that I had on our previous slide. We get a selection, bind it to data. Here we're passing a function which returns data.id. This just tells D3 what to track. What's a unique property in our data? Like, how can we tell that the data is the same or different from before? We can look at the ID for that. So this would be an important thing to use. We have our inter selection here, where we append a rectangle, set some attributes. This is a little refactor I want to show you. Here we're taking our inter selection and I'm merging it with our update selection from before. And this gives us the inter and update selection. This is basically just all of the elements that exist on the page. And then from there we're setting the Y position of R and the width of R. Again, using our scale. And then for all the bars that are being removed, we're just moving them from the top. This is probably a lot to grasp in a couple minutes. Like, this took me a couple weeks to really wrap my head around, but this is a great thing to come back to, I think. So now we can add our axes. And each axis needs its own group to be drawn into, so here I'm just making a bunch of different groups. And I'm calling this translate group function on all of them, which translates them a little bit to the left and a little bit down. And this is just to make some room for our axis labels. You can see there's now some space on the left and on the top. So now we want to display our bars not in the total width of the container, but in the width of, like, we need to take the margin into account. So for the range, instead of just setting it between 0 and width, I'm now setting it between 0 and the width minus the margin. Does that make sense?
Where does your margin get calculated? So if you change the font size, does it automatically know?
No, I just set margin as, I just hard coded up here as a variable.
Okay, so if you like control plus it, is it going to then put your labels over your squares or?
No, because I put the bars in one group, the axis in another group, and then the top axis in a third group.
So it calculated after render kind of thing. So is that what happens?
Well, they're all getting the same transform applied to them, so they're all being like moved by the same distance.
I see.
So they're always just going to line up. I'm making, we need a Y scale now for the labels. This is made with scaled band. This is just a scale for adding labels to a bar chart, basically. The domain is just going to be an array of strings, which are your labels, and then the range will just be the height of the chart that you want to display the labels in. It's pretty simple. But I'm setting those things here based on our data. To draw the axes, we need to use this call operator. And we are constructing axis top, axis left. The top and left just tell D3 where to draw your labels. And we're passing these two axes are different scales. The X scale for the X-axis and the Y scale for the Y-axis. And then all this other stuff is the same code from the previous slide. Is it kind of making sense? Now we can add transitions. And I just want to show you how easy this is by going back to the previous slide. Say we want to transition this axis. Instead of just calling call, you can just call transition. And now the axis will automatically transition. That's how easy it is. And what this is doing under the scenes is you can call transition on a selection, and transition will return a transition object. And this object has a lot of the same operators that are on selection objects. So you can call, you can set attributes in accordance with a transition. Well, here, I'll just show you on the next slide. So here I've applied all of the transitions that make sense, so you can see everything move around smoothly. If we go down to our general update pattern, here, I'm calling transition. I'm setting a duration of 2.25 seconds when the axes are being drawn. Here's our update selection, where I'm telling it to update Y and the width after 2.25 seconds. Down here for inter, there's some things I want to do immediately. Like I want to append a rectangle, set a couple attributes, set opacity to 0 immediately. And then as a transition, I want to transition the width and the opacity. And then for our exit selection, I am creating a transition where after a second, or over a second, the opacity and the width are being transitioned down to 0. And since transitions are asynchronous, we need to wait for this end event before we remove the element from the DOM. Otherwise, we'd be removing it before the transition actually occurs. So I think that something like this is where you start to see the declarative API come to life, because this is kind of describing what our graph should look like as a function of data, right? You know, it should have these attributes, which are mapped to these data attributes. It should have these transitions. It's kind of makes sense. It's not a procedural approach. You know, it describes the result that you want. So our last step is to actually connect that to real data. I'm taking all the same code from before. I'm just adding a data name argument here to our draw function. This is just so we can draw, instead of drawing data.width, we can draw data.whatever. And then I'm exporting this function. I won't go too deep into this, but I have some code here which reaches, you know, it has a couple of URLs saved for the API, the GitHub API, a couple field names for the data fields that we want to display, and then a function which is called in response to this guy being changed. So to look at the repos by the most number of stars, we are visualizing the stargazers count property, and then for the forks, it's the forks count property. And down here, after we get our data, we're calling draw chart with the data and the field name that we want to visualize. So that's kind of how you do it. Any questions about that before I move on?
So I'm missing it. Like usually you have like D as your like iterator, and then you like say your identity function. D is my iterator through the data. Take D normal. It's an object D dot width or something like that.
Yeah.
But if you wanted to say scrub that before you actually return the value, you like throw this object away because or throw this entry away because it's not complete or it's not something I'm looking for. Is that like some view chain on like a filter of some kind before you get to that point?
Yeah.
Okay.
Yeah, if you want to draw, like if you want to make, you know, these red and those green, then you would use that filter operator to filter your selection before you apply those like color transformations.
And then I assume filter has access to more than just data, because, or would you reassign an attribute every time on every element so that it's available later on?
I think for the filter operator, it basically is just going to return a new selection, which you can perform other operators on. And then if you wanted to, again, call an operator on all the data, you would just have to get a previously saved selection or get a new selection. One thing I wanted to point out, when you're binding data to a selection, it's actually binding these data objects from your array of data to the DOM elements themselves. If you look at these DOM elements in the Chrome DevTools, they actually get a new property assigned to them, which is like _data, _. It's not meant to be accessed directly, but the point is the data exists on the element themselves and not the selection. So if you ever are selecting some elements in a new selection that is different from a previous one, you can still have access to all the same data. So data is like per element, not per selection. So that's kind of a complicated hello world for D3. I quickly want to talk about D3 Force because this is one of the more fun ones. D3 Force allows you to actually do physical simulations on DOM elements. So in this example, I'm just moving the mouse, it's creating a bunch of circles, and there's a force here which is used for collision detection. So these circles are getting out of their own way. You can take a bunch of forces and add them together. Let me make this a little bit bigger. So here's an example that makes a bunch of circles, and there's a lot of stuff happening. There's an X force and a Y force, which directs these circles to their specific zones. There's a force for collision detection, and then there's a repel force, which keeps all the circles away from each other. This is really simple to set up, and I want to show you the code. So here I'm just grabbing the width and the height of our window. making an empty data array here. Here I just have an array of some hotspots that I made with x and y values based off of multiples of the width and height, along with some colors. Here I have a function called onMouseMove, mouse move event. So whenever we move the mouse, it gets the mouse's x and y coordinates and pushes a new data object onto our data array, which includes x, y, a random value for a radius, and then a random hotspot from our list of hotspots. Another thing that happens is it will register all of our data as nodes in our simulation object. To go over our simulation object here, it's not a lot of code. It's really easy to do. We are creating a new simulation with force simulation. We're adding nodes to it. Actually, we don't need this, I don't think. Nope. Because we're doing that right there. And then we're adding these 4 forces that I mentioned. These strings here are just labels. They don't do anything. They're just for us, in case we want to remove a force later. But D3 force mini body is our repel and attract force. Force collide is our collision detection force, and these forces do accept functions of data. So this collision force knows the radius of the circles. And one thing we can do here to sort of like look at this a little bit more closely, say we add 10 to that. You know, these circles now have a little bit more personal space. There's more of a boundary between them because of that. We have our x and our y forces, which we give them functions which return the data's hotspot location using the x and y. And then one thing that's really important is on tick, we want to draw everything. And a tick is something that happens, I don't know, 60 times a second, something like that. It's just every single step of the simulation is going to be a tick. And for that, we just use a general update pattern. I don't have something for our exit selection because nothing is ever getting removed, but we're binding our data to the circles, and we're appending a circle, setting the radius, setting the color, merging it with our update selection, and then setting x and y values based on data.x and data. One important thing to note here is that the simulation is modifying the x and y values on these on the data. It's being set by the mouse at first, but after that, the simulation is handling all of that stuff. This is really something that's important to keep in mind because D3 is mutating our data now. So if you're using something like React and Redux, in Redux you're supposed to keep your state immutable. So if you take some data array from your Redux store and pass it to D3 Force, now you're mutating data in your Redux store, and that's bad. So it's an important thing to keep in mind, and you're going to want to make a deep copy of your data before you do this kind of stuff. But more high-level D3. It's fun. Sorry.
If you are using React and you don't have ready access to the DOM, how does that change things a lot with this?
Yeah, and that's a good question, and a problem I had to solve. Yeah, to touch on that quickly, there's a really good article on Smashing Magazine about this. They give you a couple of different approaches. The approach that I took was kind of the most basic one, and that you don't want React and D3 competing over the same pieces of DOM because they both mutated. So what I tried to do is I wanted to create a very strict separation between the DOM that D3 would alter and the DOM that React would alter. And what I did with that is I made a React component. It wasn't a functional one because I did want to use the React lifecycle hooks. So when the component is mounted, I create a ref of like an SVG element, and I pass that to whatever D3 code I have. And then inside the should component update function, that's where you have access to next props, the data that's going to be changing. You can pass that data to D3, and then it can do its updates. And then what I like to do is just for should component update, I always return false. I just want to tell React, like, yeah, make that SVG element, give it to D3, and then just leave it alone. It seems to be a pretty good technique. It's a simple component to make, and I haven't encountered any bugs or issues with it. So.
And all your D3 is going into that component.
Mm-hmm.
Okay, cool.
Yeah. D3 might attach event listeners outside of that component, like it likes to attach event listeners directly to document or body or something like that, but I haven't seen any problems with it. It seems to work quite well. Forces aren't just fun. They can give you useful insight into your data. One thing that is neat to do with forces is to display a tree. And this is done, I really like this because it makes your data feel like very organic and alive. This is done with some link forces where it's just, and the links are highlighted with these lines here, but we can drag this data around and it just gives this tree a really nice layout. And we didn't really tell it to do anything here other than we defined some forces and gave them different strength values and things like that. This was a demo made by the creator of D3. This is not one that I made, but it's a fun demo of what forces can do. So I do want to touch on testing a little bit because D3 is really fun to use, but you're going to put it into production and then you're going to have your Scrum Master asking you where your tests are and how do you make sure that this stuff is quality. You have a couple options. Unit tests, kind of the only thing you can use unit tests for are any utility functions that you make that accompany your code. Any like I made a function that transforms Cartesian coordinates to polar coordinates. I made a unit test for that, but that's about it. Just snapshots with JS DOM is another approach. I don't like it a whole lot for D3, but I will show you a little bit about it in a second. Behavior testing with Cypress is by far my favorite method of testing D3 code. What I find with D3 is the difference between a good visualization and a bad visualization, it's not going to be a couple big things, it's going to be many small things, it's going to be lots of tiny behaviors. And Cypress allows you to test all these different behaviors individually. And what can make unit testing D3, unit testing is hard with D3 because these behaviors often don't have a one-to-one mapping between the behavior and then the code. In D3, you're using these chainable methods, so you can sometimes end up with a single JavaScript expression that's 40 lines of code or something like that. So it's hard to unit test your code when there aren't small units, And then manual testing. I have an example later. I don't know how to test it other than manually, so it's something that works. So in Jest snapshots, this is what one looks like. In your Jest tests, one technique that I have used is I've used JS DOM to create a mock HTML element that I use as a container for a D3 visualization. I have D3, I give it some fake data, and then it modifies this fake document object model, and then Jest can serialize this into a snapshot, which it saves as a text file. Looks something like this. And the idea behind snapshot tests is if your code ever changes and produces a different snapshot other than the one that's saved in your text file, your test will fail, and Jest will show you the different values. It will show you what it expected and what it actually got. It's a neat approach for testing small React components. I really like using it for that, but it can work for some D3 stuff, but I don't think it's ideal. What's nice about it is you can easily verify many values at once instead of, having a bunch of individual assertions against a bunch of DOM attributes. You can just have everything go into one text file. It fails if the snapshots change, and when they do fail, you get valuable diffs. It shows you why they failed. The stuff that's bad about it is when you make a snapshot for the very first time, you do have to manually verify it to make sure that it's correct. This is okay with smaller snapshots, but as you, I made a snapshot once, it was 600 lines. It was just a bad use of snapshots. Yeah, it's hard to verify if they're large. Sometimes you need to structure your code in order to render small snapshots, and I don't think that, designing your code that it's testable, using your tests, letting your tests influence the design of your code, that's not a very good approach. But what I'm talking about here is structuring your code so that you have a draw axis function, draw labels function, draw points function, and then you can make snapshots based off of all of those. You can't test user interactions. How do you do drag and drop? And one thing which is kind of really annoying about JS DOM is that the SVG element class is not implemented. So if you're ever calling the methods of an SVG element, it's just going to break. So I suppose that's a pretty big limitation. Cypress is one of my favorite tools for testing. It is all done in Chrome. It's like end-to-end testing. I have a demo of it in a little bit, but yeah, it allows you to automate user interactions in the browser. You can make assertions against network calls and things like that. One thing that's nice about it is it's very transparent. You have access to all of Chrome's dev tools. These tests run very quickly. It's really easy to write these tests. You can write them very quickly. You get immediate feedback. Your tests will run in a matter of seconds, like after pressing Control S. As soon as you save your code, this test is run, and then you can see it happen in the browser. Since these tests do run in Chrome and like the tests happen right in front of you, you can see them running. This is really nice for visualizations. I can imagine testing visualizations with something like Protractor or Nightwatch as being very difficult. Like, how do you test something visual from the command line? You know, it's just not a fun experience. You can mock API calls with Cypress. This allows you to completely detach an application from your backend because you can mock your calls for authentication, all of your data routes and things like that. So it works really well for like integration style tests. You can make assertions against outgoing network calls. There was a test that I wrote where, you know, in D3 you're doing a drag and drop, and on drop, Chrome is going to send some information to the server. So for the Cypress test, we can make an assertion against that network call to make sure that it's being called with the correct information. You can run these tests in the command line. It doesn't have to be run in an actual open Chrome browser. It's good for your CI/CD pipelines. And you do have direct access to the DOM in your tests, which is nice in case you ever want to, I don't know, manually grab the width of something, for instance. The only thing I could really think of is that it's for Chrome only, but it is on the Cypress roadmap to support more browsers pretty soon, including Firefox, Safari, and even Internet Explorer. I think there is a YouTube video of an Internet Explorer demo with Cypress out there. So Cypress is nice. It allows you to provide tests for all these tiny little behaviors in your D3 code. So the motto I came up with was test behaviors, not code. And my approach to writing Cypress tests is the first thing I would do is I would just sit down and write some English, just some sentences describing the behaviors that I'm expecting in my visualizations. And then once I have all those written out, I will write the tests for them. And to give you an idea of what we're talking about, this is from a tech radar that we use. I'll show you a demo of that in a second. But we have these points which you can drag around. And these labels they're not attached to the points, they're attracted to them with D3 force. And this allows the labels to kind of stay out of each other's way. There are a lot of behaviors associated with this, and you can test them all with Cypress. So these are some of the assertions that I made with Cypress, and this does a really good job of describing the behaviors that I expect to see in this visualization. You know, it should draw labels close to points. It should draw labels close to points after the points are dragged. And the list goes on. Yeah, when you test behaviors in D3, you can actually cover quite a lot of ground. So we're near the end. We've gone over a lot of the mechanics of how to use D3, what D3 actually is. But say you want to set forth and start using it yourself, what do you do? It's kind of a crazy library to use, so I have some suggestions. First thing is just Google stuff. You know, D3 is the 9th most starred library on GitHub. It has a massive open source community around it. People have made a ton of examples. If you just stick to the documentation, you know, it's very dry and technical. I find that a faster route into getting into D3 is to just look at code that other people have written and starting from there. Look at examples, look at the code in the examples. If you have an idea of something you want to make, try and find something similar and use that as a starting point. There's a great website here, and this link will be at the end, but Actually, I can show you what it is over here. Mike Bostock, he wrote D3. He's the mad genius behind all of this stuff. And he has this website here with a bunch of different examples. And it's just a gold mine. There's so much crazy stuff in here that demonstrates a lot of different techniques, chart types that you can make with D3. He does a lot of stuff with map projections and GeoJSON. Some of these things are just like displaying the features of D3 color interpolators. It's just endless, you know. And it's also just a great source of inspiration. If you have some data and you want to get some insight into it, but you don't really know what it should look like, you can come here for some ideas, and if you find something that you like, you know, start there. Like, what is this guy? This is pretty cool, you know. And all the code down here, this is how he made it. So definitely come here and check it out. There's a saying that immature poets imitate, mature poets steal. I saw that online the other day. I thought it was sort of relevant. I'm not advocating IP theft here, but like, there are a lot of examples out there. Check your licenses, but if you find a visualization that's close to what you want to make, take the code and use it as a starting point. You know, it's an easy route into getting this stuff to work. You know, I have this TechRadar demo coming up, and it uses polar coordinates. I didn't know how to do a chart with polar coordinates, so I actually took it's somewhere in here, there's a polar chart, and I used that as the starting point. So there's a demo here that I made, and I didn't even start from scratch on it. I used one of these. So I checked the license. The D3 documentation is very good, a bit dry, but it's thorough. But definitely use it in conjunction with examples. And then the source code, of course, is very good. It's extremely well designed. There's some crazy stuff happening in there. And I definitely had to dive into the source code to work my way around a couple bugs. And also, I mean, D3 is its source code. Nothing is going to teach you D3 like the source code. So it's a fun thing to check out. Yeah.
Tim, yeah, I just wanted to share that I also worked with the D3 like beginning of the year, and I was doing scrollytelling. So if you guys want to check that out, just Google scrollytelling. It's basically telling a story through scrolling through the page, and D3 was perfect for it. So that's a good starting point.
Nice.
So,
What's it called?
scrollytelling.
Scrollytelling?
Yeah.
Scroll, right?
Yeah.
Scrollytelling.
Scrolling.
It's like storytelling, but scrolling.
Scrolling telling. Okay, D3 is really good for scrolling telling. We'll have to check that out. That sounds fun, though. So this is an important question: how to gain insight from your data. You know, say you learn how to use D3. How do you make it useful now? I don't really have an answer to this one. There's no formula, like the GIF. There's no formula to get insight from your data. It's something you're going to have to get creative with. You're going to really have to use your imagination. What I hope to demonstrate with a couple of my demos is just how I tackled this question, and yeah, I don't know, hopefully it helps. So yeah, it's demo time. I do have a Cypress demo, but I want to demo what I'm testing first before I show you the test for it. So let's see. Oh, you know what? So here at Kenzan, we have a practice. That's not it.
We look at Black Friday deals.
We have a tech radar here at Kenzan, and it's something that we like to use to be aware of all the emerging technologies that are out there, the ones we want to try eventually, the ones we want to adopt. It's an idea we kind of got from ThoughtWorks, and this is what the ThoughtWorks tech radar looks like. This circle in here is the radar itself, but we can look at a quadrant, and this is what it is. So there are different zones. These are things we want to adopt. This is trial, assess, and inside there are a bunch of, like there's WebAssembly, this is Troposphere, a bunch of different technologies. It's a really cool idea, but we wanted to make our own radar so we could put the technologies that we care about on here. But this is not a super good representation of a radar. I mean, you can only see one quadrant at a time. Everything feels very static. We wanted to give people the ability to drag and drop these around. People wanted the ability to add and remove rings. Maybe we wanted more than 4. Maybe we want the rings to be different sizes. Like, do we want to zoom in and zoom out with these things? And we also wanted to be able to see the names of all of them at the same time. This can be kind of tricky because our tech radar is pretty crowded. But D3 to the rescue. So this is a prototype that I made for the Kenzan tech radar. Yeah, and as we can see, we can drag and drop these points around and they represent skills. But this middle ring here is pretty crowded. It's the core ring, it's the most important one, but it has the most points in it. What's a little weird is like all these rings are equally spaced, so it means the most important ring is going to have the smallest area, and this unimportant ring is going to have the most area. So one idea that came up is like maybe you can change the ring size and then adjust all the data inside so that each point stays inside the ring as you adjust them. That kind of sounded like a headache, but I realized that D3 has a really elegant solution for this, and it all has to do with that D3 scale library. So what I did is I made a D3 linear scale as before, but instead of just passing 2 values for both the domain and range, I passed a bunch. And what this does is it creates a polylinear scale, so it maps different chunks of your data to different pixel widths. And what that allows us to do is sort of change the view of our data without having to change the data itself. So I made a preset up here at the top. You can go from having equal width circles to equal area circles, and it transitions them all automatically. And this already is a much better view because this important core circle is huge and the points have a lot more room. So I left these coordinates up here to show you I'm not actually, I'm changing the scale of how the data is displayed, and I'm not actually changing the data itself. Another neat feature that I was able to add is sort of like an edit mode, which creates these triangles. And this lets you change the ring size yourself. And all this is doing is changing the domain on the polylinear scale and then calling a draw function which uses the general update pattern. So it's really fun because there's kind of a lot going on, but it was so easy to implement this. So I added some other features where you can zoom in per ring like that. And again, this is just changing the scale. This is shrinking the domain from 0 to 500, say, to 0 and 300. This is just reducing the data that it's showing. And then I also added a filter to the data where, if it's outside the range of what I want to display, then its opacity gets transitioned to 0. So we can see that gives it a nice fade out effect for the data that's leaving. So that's really nice. And then, of course, there's the issue of the labels. So if we look at the labels, these are all fake, by the way, but there's a lot to see. But these labels are all staying out of each other's way, and this was all done with D3 force. So if we drag one of these points around, we'll see that there's a little bit of a delay, and it's because there's no, there's nothing binding a point to its label. This label is attracted to that point with the X and Y forces. I also added some collision detection so that as you move it through your radar, it's able to stay out of the way of other labels. So this was a cool solve to see a bunch of labels at once and not have them overlap each other. And we can see them readjust if you change the scale. It does get a little bit crowded if you shrink this first ring down, but there are no overlapping labels. I had so much fun doing this because this is like the first time as a front-end developer that I've dealt with layout using physical simulations. But yeah, it's a neat approach. So if we want to look at this in Cypress really quick, I can show you that. Cypress is, you just install it through npm, and then you can run it from the command line, and it opens up this window here. So I wrote this test file, which is going to be somewhere. Yeah, this is my Cypress test file. I had an interesting problem trying to test the labels because they all use physics, you know. It's kind of random and non-deterministic. It would be crazy to try and make assertions against like fixed pixel locations of those labels because they could change at any time. So Cypress uses the chai assertion library under the hood, and I wrote a function to augment that assertion library. And it basically accepts two elements and just figures out if they're close enough to each other. You can give it a threshold, which defaults to 60. And if these two elements are within 60 pixels of each other, the test will pass. And if they're outside of the threshold, the test will fail. So if you've used something like chai before, you know, this probably looks pretty familiar. Here we're telling Cypress to visit our website. We're clicking on the show labels button, and then we're waiting for a second because these labels do need some time to sort themselves out. Before each test, I'm getting the elements, the SVG elements of the labels and the points. I had D3 assign these data attributes on there. This is solely for testing, so that there's an easy way to grab them. This is something that's described in the Cypress documentation as a best practice. And then I'm assigning them to aliases. So our first test, it should draw labels close to skill points. We're grabbing a skill, and then once we've grabbed the skill, we grab a label, and then we assert that the label should be close to the skill. So if we look at that in Cypress, which I might, I'm not sure if I already have that one running. Yeah, here it is. This is what Cypress looks like. This is Chrome. Here are the tests that we want to run, and then here's our application. So if I restart the tests, it goes through them quite fast, but we can see it actually changing our application as it goes through them. It's super useful for D3s because we can see exactly what's happening. Another cool feature of Cypress is if we look at our tests, we can actually go back in time and see what's happening during each step of our test. This is really useful if our tests fail. We can pinpoint why that is, and you know that is information that's really valuable to developers. You got to know what bug you're trying to fix, you know. So, you know, with Cypress, you can tell if like a network request failed, or if an element wasn't in the DOM, or if there is some kind of JavaScript error. You can really pinpoint it and see when it happens too. So that custom assertion that I wrote, you can actually give it some language. So here it says expected the label to be within 60 pixels of the skill, and it was 45 pixels away. Pretty neat test. One thing we can do is change the threshold if we want to see the test fail. Change it to 10 pixels. The test failed, so we expected it to be within 10 pixels of the skill, and the label was 45 pixels away. So these tests are pretty easy to write, and you know there are a lot of tiny little micro behaviors associated with the dragging and dropping of these skills, and you can cover quite a lot with Cypress. So I definitely recommend this for testing your D3 visualizations. And since you can mock out your backend endpoints, you can serve up the same set of fake data for all of your tests. And you don't have to like rely on data on the server not changing and not breaking your tests. You know, you can keep your test data sort of isolated from the rest of the world. Any questions about this?
In your CD platform or whatever, does it just run headless Chrome? So if you're doing like something else, there's an equally implemented like headless IE, headless Firefox, anything like that?
There's no IE or Firefox yet. I think there will be. It's on the roadmap. But yeah, in your pipeline, you could just do this on the command line, and then it just shows you the output of your tests here. But it's basically just the same thing, but yeah, headless. Two more demos. This is a pretty basic one, I think. This is a Gantt chart. It's supposed to be timelines for a bunch of different projects. They're just sort of arbitrary events that happen in these timelines. There are tooltips, but this uses, axis, it uses zoom, and it uses scale, and that allows us to zoom in and out. And this lets us look at projects that are on a scale of a few months to projects that are on a scale of a few years. This one's relatively easy to implement too. We have a listener for the zoom event. This figures out what our new scale should be. It calls a draw function, which then has to redraw every line and rectangle. But D3 does do that very efficiently. And this is the example where I'm actually using a foreign object. These labels are all spans inside of a foreign object. And this lets me truncate them with an ellipsis if the width of their container gets too small. So, as we zoom out or zoom in, we can see that, there's a tooltip here, but we can see the names sort of changing and getting truncated with that ellipsis, and it's CSS that's doing all the work. It's also using the general update pattern with transitions on enter, update, and exit, and this gives you some cool transitions which preserve object constancy when the data changes. So here we can sort by start date. We can also reverse the sort. We can also sort by end date, so like that. And these transitions help your eye see what's staying the same and what's changing. It's way better than the stuff happening
And that's
instantly.
D3 doing this sort. You're not sorting it using any internal JavaScript. It's D3.
I am sorting the data array
Okay.
using regular JavaScript, and then I call the draw function with the new data.
Okay.
So, but the data objects do have IDs on them, and that's how D3 knows what's the same, A fun little minor demo. So the last demo that I want to show you, I'm almost done here. This, I had this question, how do you get insight from data? And about a year ago, I was looking at the Spotify API. There's the stuff you'd expect to find here, getting information on artists, albums, the user. But down here in tracks, there's an endpoint for audio analysis. I discovered this about a year ago, and I'm just like, what on earth could this be? So we look at it. You give it a track ID, and then it returns this object here. It has an array of bars, has an array of beats for the song, sections, segments. Each segment has an array of pitches with confidence values in them. It has timbre, tatums, which I had never heard of a tatum, but there's a definition down here somewhere. Has nothing to do with art tatum. A tatum represents the lowest regular pulse train that a listener intuitively infers from the timing of perceived musical events. That's a tatum. So I'm like, this is crazy. What is this? What does this data actually look like? So I went out there. A lot of windows open. And I grabbed the data for a real song. This is, it's about 4 minutes in length. And if we take a look at the data, there's a bunch of metadata here about the track. But then we have our array of bars. So these are all of the measures in the piece of music with start times, durations, and confidence. We'll just collapse that. There's an array of beats with all the same values. An array of tatums. An array of sections, and a huge array of segments. So each segment is, there are many segments per beat to give you an idea of how many segments there could be in a song. There could be thousands. And each one has an array of pitches. It has information about loudness. Also a start, duration, and confidence. But like this array of segments, this whole thing is 55,000 lines of JSON. It's over a megabyte of JSON. It's just like a massive amount of data. And when I saw this a year ago, I'm just like, this is crazy. Like, is this even cool? Is this data even right? Does it line up with the music? Like, I had all sorts of questions, and they were just sort of bugging me for a while. But once I started to learn about D3, it all clicked that suddenly I could do something about this. So this is live right now. It is very much just a prototype, but there'll be a link at the end. It's hosted up on GitHub. I call it the Spotify Song Explorer. When you come here, you'll have to log into Spotify with OAuth, and you do need a premium Spotify account for this, just because it lets you play whatever track you want. Can I move this bar? Yes. So what we can do is we start out by picking a song. I like to use Billie Jean. Spotify is just very confident about the beats in that. It's a great song for testing.
Whatever you need to tell yourself, bud.
I got some volume here. So we pick it. Yeah. So it uses the Spotify web playback API. So it actually plays back the song. This shows you, if Spotify's analysis is actually lining up with the music. There are these circles here which occur at the same time as the beats and the tatums and the bars. This gives you like a nice visual idea of when these things are happening. And it's mostly correct. But this is most of the data in that massive object that I showed you earlier. There are a couple options down here at the bottom we could turn off the confidence. So this is just showing you where it thinks everything is. You can turn the confidence on, and it changes the opacity of each section based on the confidence value. We are mapping the confidence value to a visual attribute. This is a document driven by data. But this also uses D3 Zoom, so we can go in and actually take a closer look at things. These segments at the top, they just represent volume. And it's kind of interesting because, in this song, if we go back to the beginning, we get a pretty clear visual representation of the jet. You see these segments, just like loud, soft, loud, soft. We can tell that this is a dance tune because there's not a lot of dynamic, the loudness is pretty flat throughout the whole thing, and also there's a lot of, it's pretty harmonically simple. The pitches aren't really changing a whole lot. It is neat that you can see patterns in all of this. Like something changes here, so this has to be a chorus, right? We go up here. Yeah.
So this is how Shazam vectors a song or something like that and finds it?
I don't know.
Well, giving confidence scores, I assume it's machine learning in some way on their internal, what it actually uses, because it's coming from Spotify, but it must be machine learning with confidence score.
Yeah. What's interesting about this array of pitches is there's one value for each pitch. They don't represent the 88 notes of the piano. It's just saying this pitch is happening somewhere. But it seems to assume that there's only one pitch that is predominant. So I made a pitch threshold down here, and you can actually increase it to filter away the pitches that it's less confident about. And there's also a rhythm threshold up here, so you can sort of filter away the rhythms that it's less confident about. Yeah, and then this is just what pitch it thinks is currently most prominent. Show you another example. Bohemian Rhapsody. A lot more dynamic variation. It's not flat, and a lot more harmonic variation too. We can can see the harmonies changing as we go through. What's kind of interesting about this one, get some volume here. If we go up here to where the song kind of starts, there's stuff happening in the melody, but it is like, this has to be an A sharp. This has to be a G. And what I realized is that it's really paying attention to the bass here, which is kind of interesting. And these are the pitches that the bass is actually playing. So if you're a bass player, you can come here and learn the song. It's pretty easy. There are some drawbacks, like there was a rock song that I was listening to, and I guess the bass drum was tuned to a certain pitch. And it just said, like, there's a C sharp happening in this whole song, and it was just the bass drum. So, yeah. Here we can see a descending chromatic line in the bass. So, it's kind of neat. One last example. I could take some requests too. But this is all hosted, so you can go play with this yourself. This is a cool example of what the tatums are. So this is some classical piano. Oh, that's not what I wanted. Is this it? A lot quieter. So there's this. It's got some swing to it, you know. It's just 4/4, but it's got like a dotted 16th pattern. But we can see this reflected in the tatums. If we zoom in, these beats are steady, but these tatums are not. You know, it's long, short, long, short. And we can actually see this here. So I thought it was really cool that Spotify was able to pick up on this. Yeah, a lot of fun stuff to see here. It does have its limitations though, and it definitely makes a lot of assumptions about tracks. If you put stand-up comedy in here, it's going to tell you that it has beats and measures and stuff. But it is kind of interesting.
I have a friend who recently turned 30 years old. He had other options.
That's what's happening. None of this is right, you know, but it's still relatively confident about some of it. But it's kind of cool is if you zoom in a little bit, you can actually see his voice changing pitch, and then this whole wall right here, that's laughter. Like you can see patterns in this still. So if we go up here, laughter. So yeah. So cool. This was interesting too because you know I showed you the general update pattern and all that fun stuff and SVG and D3 selection, but this uses the Canvas API to draw all of this. Drawing this many rectangles with SVG is just it's going to be like half a frame per second. It's slow. So in order to get this to be smooth, I had to use the Canvas API. To show you how that works in the code, because it's pretty different. Oh, it is. So there's a lot of stuff going on here, you know. I'm defining my scales, my axes, a bunch of groups. But down here, is there settings? Okay. Just the key that I did with. So I still have a draw function. But when you're dealing with the Canvas API, everything that you know about the general update pattern and all that stuff just goes out the window completely. Because the way the Canvas API works, it is just a single element, and you have the commands like clear rectangle, fill rectangle, draw rectangle, things like that, and it draws inside this one element as if it's a canvas, you know. But in order to change things inside the canvas, well, there isn't a way to change stuff. What you have to do is clear the entire canvas. You erase everything and then redraw everything. So as I zoom into the visualization, that's what it's doing many times per second, is just erasing everything and then drawing everything. Surprisingly, it's very fast, even though it does have to go over every single piece of data from that massive JSON file, as we see here. You know, for every data, beat, bar, and section, you often use for each. We're iterating over the data. And these are all names of arrays, so for each one of these arrays, set some styles, do things whether or not that show confidence setting is on, and then fill a rectangle, which is like the inside of a rectangle, and then draw the rectangle, which is the border around it. This is all kind of messy, but there's a lot of math going on right here. But this is a scale. This is a scale linear that we've seen before. For all the segments, same thing for each segment, and then for each single pitch inside the segment array that's on each segment, set some styles, fill the rectangle, and then draw the rectangle. And again, we're using an X scale here and a Y scale. With an X scale, we want to map the data to the entire width of our container, and in the Y scale, we just want to map the data to the amount of space that I allocated for all the pitches. So it works surprisingly well. And this is the one that I really have no idea how to test.
Yeah.
How do you write a test that makes sure the circles line up with what you're hearing? Like, how do you even test the Canvas API? I don't know how to do that.
That's into a screenshot. Test the pixels.
Maybe. You can get an image from a canvas as a bitmap. So maybe you could grab that, do some kind of visualization. I don't know. But yeah, so that's my final demo, and that's all I got. I do have the last slide here. Thank you for coming. These are a bunch of useful links. Take a picture. Yeah. Any final questions?
If your data is in a CSV file, is there any pre-processing steps required with D3 to work?
Possibly, but of all of those modules in the D3 ecosystem, there's actually D3.DSV, and it's a bunch of utility functions for delimiter separated values, like CSV or TSV. I haven't used it, but CSV parse could probably be really useful.
Any other questions for Tim? There was a whole lot to process here. That was great, Tim. Thank you very much.
Thank you.
So yeah, these slides and the video are going to be posted in the meetups if you guys want to take a look later. Yeah, next month we've got Loopback presentation, Loopback version 4, which is, if you're not familiar, Loopback is an API framework for Node. They just released to general audiences recently, so it's fairly new. Pretty exciting. It's using TypeScript and a lot of modern stuff, so GraphQL, things like that. So yeah, that'll be next month, I think on the 15th, but check the calendar to be sure. So yeah, thanks for coming everyone, and have a good night.